Suppose you invest an amount of P dollars on a cumulative deposit account paying 2.75% interest compounded continuously for a period of 3 years. At the end of 3-year period, you get $868.80 back from the bank. How much did you invest originally? Hey, how are we doing? This is Dr. Nandi. We are working on a compound interest problem. So let's get started on this. So let me change the color of my ink. Okay. This is a continuous compounding problem. Okay. So we are using a continuous compounding situation. Okay. The formula for it is the future value f is given by f is equal to p multiplied by e raised to the power of rt. So f is your future value, I already told you. So P is the original investment. Okay. R is the annual interest rate in decimal value. Annual interest rate in decimal value. Okay, and T is the number of years of investment. So we are going to use this formula. Okay, we have been given a future value, we have been given a rate, we have been given a time, but we do not know the original amount of investment. Is that clear? So we know the future value, we know the rate of interest, we know the time for which the amount was invested. Only thing we do not know what was the original investment amount. So our future value was given as 868.80. Okay. Our rate is given as 2.75% per. So let me erase that and write it nicely. So rate is 2.75%, or in other words, in decimal, it is 0.0275. Okay, time period of 3 years. Okay, so let's plug it in. Okay, we have to use our calculator because we have an E. E is the natural number. Okay, so the calculators have a key for that. Okay, natural number. Okay, so my future value is 868.80. My P is unknown, that is not known, that is the question mark. Okay, multiplied by, this dot is multiplied by E, the natural number, raised to the power of 0.0275 multiplied by 3 years of investment. Okay, so in other words, 868.80 is equal to P times E, and if you multiply the two exponents together, you get 0.0825. Okay, so now I'm going to use my calculator to figure out the value of E, which is the natural number, raised to the power of 0.0825. So it will be 868.80 using P equal to P multiplied by E raised to the power of, in my calculator there is a key to do that. I am using TI-84, and that value works out to 1.086. Now I will divide by divide by 1.086 on both sides to get 868.80 divided by 1.086 is equal to principal multiplied by 1.086. That also is divided by 1.086. Now we can cancel 1.086 from the numerator and denominator on the right side and solve for P. P works out to $800. That's your final answer. So, summarize, what did I do? I wrote the formula for continuous compounding, which is F is equal to P. P is the original amount of investment, F is the future value, multiplied by E. What is E? E is the natural number, 2.718. We will use the calculator. R is the annual rate of investment or annual rate of interest in decimal value, and T is the time of investment in years. So we plug it in, substitute all the values given to us. For example, F is 868.80, P is unknown, multiplied by E, rate of interest is 0.0275, annual interest rate, multiplied by T, T is 3 years of investment. And we find 868.80 equal to P times E, the natural number, raised to the power of 0.0825, which I find in the calculator is 1.086. I divide by 1.086 on both sides. Finally, I solve for P equal to 800. I will stop here. If you have any question, comment, write me a question. I'll get back to you as soon as possible. If you like this video, please do not forget to give me a thumbs up. I really appreciate that because your thumbs up motivates me. I work harder to produce more interesting videos just for you. Okay, and if you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button on the bottom right corner. And please do not forget to watch me tomorrow when I'll be back with another interesting video. Please subscribe to my channel by hitting the red subscribe button, and please do not forget to click on the bell because that will notify you every time I upload an interesting video. Thanks for watching. Take care. Have a nice day. See you tomorrow.